So this is a question where you're given a graph of distance versus time, and you're asked to draw a velocity versus time graph. So in all those cases, what I'm looking for is a sense of the sign of the slope, positive or negative, and a sense of the how steep the slope is. So let's actually do this. Just a quick reminder. Positive slope so positive slope means positive velocity, which will be above the time axis. And increase steepness corresponds to increase speed. I'm using the word speed there because I'm talking about how fast, magnitude, not direction. And increased speed would be farther away from the time axis on the VT graph. I guess I should have written that up here on the VT graph. So let's go ahead and start. Okay. So when I look at this first stretch A, see that I have a line that is negative in slope. So I'm going to have something that is negative velocity, so I will be below the time axis on the velocity graph. And the slope is decreasing, so I'm going to start far away from the axis and make my way towards 0, because when I get to B, velocity equals 0. Here, velocity is less than 0, it's negative. So when I go down, I'm going to be on the underside of the velocity time graph. I'm going to start out with a negative velocity and make my way so this is A. Make my way towards 0. At B, as I said, we are at 0 velocity because the line is flat up on the dt graph. So that's B. Then, up at point C, the velocity again is less than 0, but it's a constant slope. So there's no slowing down or speeding up. And I'm going to keep talking about this stretch here. Notice this whole stretch from C all the way down to that point is one constant slope. There's no change in velocity. What happens at point D is just that we pass our midpoint. We're past whatever we call 0 meters. We've passed the start line. But it's not going to cause our velocity to change. So when I go down here, I'm going to drop down oops, I didn't want that to be blue. So this is really B, D, or C, D, and E. I'll connect it. So all D represents, let me just write that in, is we pass 0 meters. Now, something interesting happens here at this point. I should have labeled it. I didn't give it a letter. What's happening here is we're going from positive to negative velocity. So the sign of the velocity changes. Because the sign of the slope changes. And what that means is this is a change in direction. And so we're going from positive velocity to negative velocity. And if you look at the slope from B to E and compare it from F to H, say F to H is a little steeper. So the fact that it's a little steeper, and I'm talking about this stretch in here, it's positive, so V will be greater than 0, but it's constant and steep. So I'm going to need a constant positive velocity graph down here. So positive puts me above the line, constant means it's going to be flat, but it's not going to be, it'll be farther away from the x-axis than my last flat straight line. So I shall go like that. And I'm going to, again, I'm going to connect it, and this is point F. G somewhere in the middle here, and then we have H. I'm going to mark this point on the graph with a red star, because this represents the change in direction point. So this point here corresponds to this point here. Those are the same places in time. The last stretch. So when I look at H to I still have positive slope, but it's becoming less steep. Positive slope becoming less steep. We're slowing down. And in fact, when we get to I, V will be 0 again. So what this means down here is I'm going to have a line that slopes down such that when we get to I, it is a flat line. A few last things. In this class, whenever you see a curve on the DT graph, you can assume that all curves are parabolic. This is not true in the real world, but it's true in our class right now. So all curves on dt graphs are parabolic. What this means is that d is proportional to t squared. And why? And it actually, if you think about it, all of our numerical equations that involve acceleration, d is proportional to t squared. But why this is important, it leads us to that constant acceleration. And for a question like this, perhaps what is most important, you will have only straight lines on the VT graph. As I said, the real world, that is not the case, but for mathematical simplicity, that is what goes on here. And that's the end of this lesson.